So we have looked at the class diagram, at the first class diagram of our system. We have looked at an object diagram. We have looked at a sequence diagram. Let us look into some more details of our system, of our model. This is the use file, the use model, the textual use model, and as you see we have the class user with attribute and operations, we have the class copy with attribute and operations, we have the class book, we have the textual description of the two association borrows and belongs to, and here in the lower part we start to see the constraints. And there are particular constraints now here, and these constraints have to do with the restrictions that are formulated in the verbal formulation of the model. So there is a symbol for the class user. There is an invariant formulating a restriction on the format of the name and the address. So in particular, name and address are not allowed to be the empty string. There is a requirement that the name has to be unique. The name of a user has to be unique. In principle, we are saying we're having a universally quantified variable u1, we have another universally quantified variable u2, and we say whenever we have two different users, u1 is different from u2, then this implies u1 and u2 should have different names. There is a further restriction in the user class that says no double borrowings. Let me explain it in the object diagram what this restriction is for. In this situation, Ada has already borrowed an exemplar of the datebook. Yeah, Ada has a link here. And in order to have some kind of fairness and in order to allow Bob to sort of borrow this second exemplar of the datebook, there is this constraint. Namely, when Ada has borrowed an exemplar of a particular book, Ada is not allowed to borrow a second exemplar of the same book. And this is what the constraint is about. So, for you, a user, the invariant is called no double borrowings, it is formulated as follows. It is kind of a description of a negative situation. It should not be the case that when I'm navigating here from the currently considered user, u.copies from the user to the copies of the users. It should not be the case that this user has borrowed, this copy is the role name in the association borrows. It should not be the case that this user has borrowed two copies, C1 and C2. These are different copies, and these copies belong to the same book. This is simply structurally not allowed. So it's this no double borrowings is kind of a fairness condition, and that's formulated as an invariant here. Let us go through the other invariants here. We have a restriction on the format of the signature. We have a restriction that the signature is kind of a key attribute. The signature is unique for a copy. So you see that this formula here is quite structurally quite the same as this formula here. The invariants are also called in a very similar way. Name is key, signature is key, and the underlying formulas here in the OCL are very similar. We have a restriction on the format of the title of a book. We have that the title is a key. Again, we see here the same structure of the formula. We also have the same structure of the name of the invariant. So titles for books are unique. The format of the entries in the author sequence have to be okay as well, not the empty string and something else here. And what is required here, I will not go into all the details, what is possible, or what is formulated here, but the purpose of this constraint is that, let me again go to the example and make it concrete in the object diagram. We have here a book, and the book has the authors of the book are El-Masri, Nawate, two authors. What the constraint requires is that in formal terms, when you have a sequence of strings here, in formal terms it is possible that the third author here would be again El-Masri. So when you have a sequence here, it is possible to have as a value here El-Masri, Nawate, El-Masri. And this does not make sense. You know, and an author occurs only once in an author list. And this is exactly specified, required here. The author sequence exists, so the author sequence attribute has to be non-empty, or not the empty sequence, and the entries in the author sequence attribute have to be unique. I will not go into all details here. And the last invariant that is formulated here, the year has a publication, the book has a year of publication, and the year of publication that was mentioned in the Gutenberg Bible was mentioned in the verbal description, and the Gutenberg Bible, the year of publication of the Gutenberg Bible 1455, and the year of publication must be later. So these are the invariants, and now we have the pre and post conditions for each operation, for the user init, for the user borrow, for the user return. I will not go into all the details of the pre and post conditions. If you're interested, go through it. I will just point to some interesting requirements here, namely for the borrow and for the return action in the user class. So the user decides to borrow a particular copy of a book, and then there is a precondition, which is a requirement here on the parameter a copy. A copy is a parameter of the operation borrow, and it says a copy.user is empty. Yeah, that's the navigation from the copy class to the user. That's the role name used in the class diagram, and the copy can only be borrowed by a user if it is not already borrowed, and the formal formulation of this is a copy.user is empty. That's the requirement for the copy. It's a requirement here on the parameter of the operation. So that's a precondition. The postcondition says, and this is something that we have not seen before, and we will see it in detail later, but it jumps here as a kind of needed thing that we need here for the postcondition. The postcondition says self.copy at pre, including a copy, is equal to self.copy. So this postcondition is evaluated after the operation has been executed. So after the operation borrow has been executed, self.copy is a set of copies that is associated with the current user. And the requirement here is, well, we consider the set of copies that the user had before the operation was executed, namely the set of copies at precondition time. And this is the set of copies that was associated with the user at precondition time, self.copy at precondition time. And then we add this copy, we add a copy with the operation including, we have seen that already, and then these two sets have to be equal. That is the contract, the operation contract, as it is also called, the pre- and post-condition of the operation borrow. The pre- and post-condition of the operation return are somehow similar in the following sense. When the user wants to return a copy, there is a precondition for this operation. Namely, the precondition says the copy that the user wants to return has to be included in the set of copies that the where were we? Here we were, that was a return. The set of the copy that is going to be returned has to be included in the set of copies that the user currently has at precondition time. So here we are in a precondition, and self.copies are the copies that the user has at precondition time when he or she wants to return the parameter a copy. And the postcondition says the lig is going to be removed. In the postcondition we are saying self.copy at pre, excluding a copy, is equal to self.copy. So self.copy here in a postcondition are the set of copies that the user is associated with in the moment the postcondition is executed, in the moment when the operation has been executed. And we here access the set of copies that were available at precondition time. So sort of this self.copy and this self.copy occurs in a precondition, and this self.copy at pre occurs in a postcondition. They refer to the same set of values. And so this is the contract, the pre- and postcondition for the return action for the return operation in the user class. I will not go into the details of all the other operations. They are more or less formulated similar. More or less this finishes the description of the first model. So the first model was the model for that was called model max invariance minimal pre and post conditions. So a lot of things were formulated in the invariant, and only a minimal set of requirements were formulated in the post condition. Let us now, so we have studied so far the informal description and this model here. Let us now come to the second model, max prepose. I told you already the class diagram for the first model and for the second model coincide. So this is a class diagram for both models. Now let us look at the difference between the first and the second model. What we see here now are as a table on the left side. We see the constraints in the first formal model, max inf min prepose, and in the right hand side we see the constraints for the second model, for the model max prepose. These were the invariants that I have discussed so to a certain degree. We have discussed also to a certain degree here the pre and post condition of the borrow user operation, and we have discussed to a certain degree the pre and post condition of the return in the user class. And if you now look here on the right hand side, you see the invariants that have been present in the left hand side model, in the first model. There are no invariants here on the right hand side. And what is formulated here in the invariants has now been transformed into preconditions. So you see the preconditions, which are marked here with star, are conditions that come from invariants. The idea is the following. Instead of having these invariants, which must sort of globally be checked, the idea is to check the invariants when at the time when a particular operation is triggered and is executed, and to formulate the invariant as a precondition for the respective operation. So, for example, we have had this invariant, the name is key for the user class, and this invariant now becomes a precondition in the class user for the operation in it. And in principle, all the invariants, you see the invariant names that were used here on the left hand side occur as names of preconditions here on the right hand side. Let us look into the details here of the name is key requirement invariant, and let me try to find the respective precondition in the second model. So this is the model max prepose, and this is the init operation. Yeah, and here we have the operation. Here we have the operation init. So this is in the second model, the model without invariants. We see here what name is key was an invariant requiring the uniqueness of the name attribute for users. And we have transferred now, or yeah, we have transformed the invariant into a precondition of an operation, the only operation that manipulates in the class user the attribute name is the init operation. And the operation has now an additional precondition. We have the parameter of this operation, of the init. The parameter of the init operation is a name. And what we do now, we consider all the condition here that realizes this precondition and that realizes the previous invariant. We are considering all users, and we are collecting here the names of the users with a collect operation that we've also seen before. So this expression here, the first part of the marked expression, the expression here to the left, are all currently existing names of users. And we require that the parameter of this operation, a name, is not included in this collection here. So what was previously done in the invariant is now done in a precondition. And this is basically the intention and the idea. Where is our table here? This is in principle the idea of this transformation, which goes from one model to a second model, and the transformation which takes the invariants and transforms them into preconditions of particular operations. So, going back to our overview figure, we have studied the informal description. We have studied the model where we have seen intensive use of the invariants. We have then transformed the invariants into preconditions, and that was the formulation for this model. Let us now jump into a different model, which is called here in the overview ASOC to attribute. And it's a model which I would classify as a more Java-like model. Why do I classify it as a Java-like model? Well, if you look at this class diagram, I have used associations here. In Java, or in nearly every programming language that I know, there are no associations. There is this direct concept of an association is not available. So when we want to implement this model, we have somehow handled these associations. And the idea is now to have this model, ASOC to attributes. We are transforming the associations into attributes. And let us look at the class diagram and how it looks like. So this is a class diagram for the model assert-to-attribute. And as you see here, we still have the classes user, copy, and book, but we do not have any associations here. Instead, we have in the classes additional attributes. In the user class, we have an attribute copy, which is typed as setOfCopy. In the book class, we have an attribute copy, which is typed as setOfCopy. And in the copy class, we have an attribute user, which is typed as user. And we have an attribute book, which is typed as book. Why is there this different typing? These 4 attributes sort of simulate these roles: user, copy, copy, book. So user becomes an attribute in copy, book becomes an attribute in copy, this copy becomes an attribute in user, and this copy becomes an attribute in book. And according to the multiplicities, a copy references only at most one user, and thus the additional attribute here, the user, the attribute called user, is typed with the class user. On the other hand, a user can borrow many copies, and so this copy becomes an attribute copy typed as setOfUser in this class, in the class user. And this is what we see here in this model: copy, setOfCopy, copy, setOfCopy, because a user can borrow many copies, a book can have many exemplars in form of copies, that's why it is here a setOfCopy, but a copy can only refer to at most one user, and a copy refers to exactly one book. So that is why we have these different typing disciplines here in the respective classes. There is one interesting thing now in these classes. We need an additional requirement. Why do we need additional requirements? In the original model, in the original 2 models, we have had here, we have had here one association. The association borrows, and in the association borrows, we have the role name user and we have the role name copy. And the association takes care that the user and the copy are inverse to each other. So anytime we have an object diagram and we have a link between a user and a copy, then the user and copy are inverse to each other. Now we have 2 different attributes. Copy is an attribute in the class user, and user is a class in the class copy. And in formal terms, these 2 attributes do not have to do anything with each other, and they do not need to be inverse to each other. The same holds for the combination copy in book and book in copy. So these two attributes are for the association belongs to. These two attributes are for the association borrows, but the attributes formally do not have to do anything with each other, and we must require that these two attributes, copy and user, are inverse to each other. And this requirement is formulated. This requirement is formulated over here in the model. In the model, of course, we're talking about the model ASOC2 attribute. Additional invariants take care that the respective attributes respecting the association ends are inverse to each other. For example, the requirement of the association borrows are characterized as follows. So we obtain here two additional invariants. And I've called the invariant user copy user is equal to user, and the other one is a symmetric one. And the requirement here is formulated as follows. When I have a user object, the user, the set of copies that are associated with the user U, the set of copies is not empty here. Whoops. Don't click. For the user, the set of copies is not empty. Read this as not empty here. Then this implies the following. When I go from the user to the copy and I go back to the user again, then I obtain a collection of users. This is an implicit collect here. This is a dot notation that we have seen. And the dot notation always results in a bag, and we must go from the bag. We can go from the bag to the set, so we convert the bag that is obtained here to a set. So this expression here on the left-hand side are the users that we obtain when navigating from the user to the copy and then to the user again. And then the user, it's the set made of the user itself, then it must be equal to this set here, because there can only be, a copy can only have a copy can only have one borrower. So it must be equal to the set consisting only of the user U. And there is an analogous requirement. It's more relaxed. It's formulated here with the includes, because that can be a set here when we are navigating from the copy to the user and then again to the copy, starting from a copy to the user and then the copies again, and then the copy again must be included there. So these are the two invariants that take care that the attribute copy and user, that the attribute copy in user and the attribute user and copy are inverse to each other.